equation. So let's look at this first equation. Remember, whenever you're solving an absolute value, you have to isolate the absolute value first. So this is my absolute value. I need to get rid of anything in front or behind the absolute value by moving it to the opposite side of the equation. Let's start with that positive 4. So let's subtract 4 from both sides. So then that gives us 5 times the absolute value of 4x plus 2 equals 50. Now we are multiplying the absolute value by 5. So we also need to divide that out. We cannot distribute into an absolute value. It is not the same as a parentheses. So we have the absolute value of 4x plus 2 equals 10. So now that it is isolated, we are ready to separate. Now, what are the two numbers that have an absolute value of 10? The first one is positive 10. So my first equation is 4x plus 2 equals 10. And the second number is negative 10. 4x plus 2 equals negative 10. So now let's solve both of our equations. In both equations, we're going to subtract 2 and divide by 4. And now let's do the same thing with our second equation. Subtract the 2 and divide by 4. So our two solutions are x equals positive 2 and x equals negative 3. Let's solve one more. So again, we have to isolate the absolute value. Feel free to pause the video and work it out on your own, and then restart it to check your work. So I'm going to add 9. And then I'm going to divide by 6. So the absolute value of 1 minus 5x equals 11. And what are the two numbers that have an absolute value of 11? The first one is positive 11. And the second one is negative 11. So now we're ready to solve. So we're going to subtract the 1. So negative 5x equals 10. And then we're going to divide by negative 5. So x equals negative 2 is my first solution. And let's do the same thing with our second equation. First, we are subtracting the 1. And then we're going to divide by -5. And let's just leave our answer as a fraction. Two negatives become a positive, so x equals positive 12 over 5 is my second solution. So let's look at this third problem here. So we have Nicole. She's sitting on a sidewalk. 10 feet away from her, Michelle is on her bicycle and riding towards Nicole and past her. Michelle is riding at a constant speed of 3 feet per second. Her distance, d, from Nicole in feet after 2 seconds can be modeled by the equation d equals the absolute value of 45 minus 3t. At what times during Michelle's travel is she 30 feet away from Michelle? Okay, well, let's go ahead and take a look at that. Whenever you see a word problem, the first thing we want to do is identify equations. We have a very important equation right here. And in this equation, we have d, which is distance, and t is time. Also, notice that it says at what time. So there's more than one answer. Because when she's riding towards her, she's going to be on one side. So if Nicole is here, there are two different locations that Michelle can be and still be 30 feet away. So Michelle could be on the left and be 10 feet away. Sorry, 30 feet away. Or she can be on the right. And still be 30 feet away. So because this is an absolute value equation, we need to separate it into two equations. First of all, her distance that we're trying to figure out times 4 is 30. So I'm going to substitute 30 in for d. So in this equation, we have 30 equals the absolute value of 45 minus 3t. Now this absolute value has already been isolated. We don't have any numbers in front or behind. So we are already prepared to separate it into two equations. So 30 equals 45 minus 3t, and negative 30 equals 45 minus 3t. So we're ready to separate. So I need to subtract 45 in both equations. And then I need to divide by negative 3. So at t equals 5 seconds, that is the first time that Michelle will be 30 feet away from Nicole. Let's do the same thing with our second equation. Subtract 45. And divide by negative 3. So the second is at t equals 25 seconds. So Michelle will be 30 feet away from Michelle, will be 30 feet away from Nicole after 5 seconds, and also at t equals 25 seconds.